Yeah, good morning, students. Today we would like to discuss about the classroom discussion topic 10. Now I am sharing my video. So the today's topic for discussion is I/O device interfacing. So the lecture objectives of today's session is this session will develop the students' knowledge in input and output operations. So how do we access these I/O devices? Generally, these I/O devices are connected to the processor via a interconnection network. For example, if you are taking here IO device 1, IO device 2, IO device 3, like that, n number of IO devices are there. These IO devices are connected to the processor via interconnection network, as similar to this memory, how it is connected through memory interfacing network. So the interconnection network is consisting of circuits which are needed to transform information between the processor and the memory unit and IO devices and the IO devices. So this a memory mapped IO, that means here each IO device each IO device must appear to the processor as consisting of some addressable location, just like a memory location, just like a memory location it is going to display for us. So some addresses in the address space of the processor are assigned to these IO locations rather than to the main memory. Okay, some addresses in the main memory is associated with these IO devices, and those memory locations which are associated with IO devices are called it as IO locations. So these locations are usually implemented as bit storage circuits, which are generally called it as flip-flops, organized in the form of registers. Okay, set of flip-flops is called it as a register. So it is customary to refer to them as IO registers, since the IO devices and the memory share the same address space. So that is the reason it is called it as memory mapped IO. So it is called it as a memory mapped IO. For example, if you take here load R2 comma data in, that means it is reading the data from the input device into the R2 register. So if you want to display the contents of R2 register onto the output device, we are using data out. Data in and data out are the input and output memory words, we can say it as our memory locations. Then IO device interface. So an IO device is connected to the interconnection network by using a circuit which we are calling it as a device interface, So this device interface will provide what we are calling it as data transfer and exchanging of this status and control information which is needed to facilitate the data transfer and which will be used for the operation of that particular device. So the interface includes some registers that can be accessed by the processor. So buffer for data transfers, which we can call it as a data registers. This will hold information about the current status of the device. that is called it as a status register. So we have the data register and we have the status register. So the data register which hold the data which you have, which we need to transfer, and the status registers will hold the what we are calling it as current status of that particular device. And control registers, this is another important register which will be used for storing the information that controls the operational behavior of the device. So operational behavior of the device will be controlled by this control register. So these are the important registers that we can use here basically. So if you see this IO device interface here, the data status control, data register, status register and control register. Okay, so that are associated with all the input output devices. So for example, standard input device if you take keyboard, and standard output device if you take it as a display, that is called it as a screen. Okay, so these are connected through interconnection network, and here the processor will have the control registers and general purpose registers will be there. So here the second method of IO device accessing is program controlled IO. So in this program controlled IO, for example, consider a task that reads a character typed on a keyboard, stores this data in the memory and displays the same character onto a display device that is called as a screen. So a simple way of implementing this task is to write a program that performs all functions needed to realize the desired action. This method is known as a program controlled IO. Through a program you are controlling this IO operation. So the rate of data transfer from the keyboard to a computer is limited by the typing speed of the user. So the rate of output transfer from the computer to the display is much higher. So this is still much slower than the speed of a processor that can execute billions of instructions per second. So the difference in speed between the processor and IO devices, the difference in speed between the processor and IO devices creates the need for a mechanism to synchronize the transfer of data between memory and IO devices. So for that particular purpose, we are making use of what we are calling it as a signaling mechanism. So for which we are using the signaling protocols. So on output, the processor sends the first character and then waits for a signal from the display that the next character can be sent. So it then sends the second character and so on. So an input character is obtained from the keyboard in a similar manner. So the processor waits for a signal indicating that a key has been pressed and that the binary code which represents the corresponding character is available in an IO register associated with the keyboard. Then the processor proceeds to read that code. So the second method which we are calling it as a polling method. So the polling method can be like this. The keyboard includes a circuit that responds to a key being pressed by producing the ASCII code for the corresponding character that can be used by the computer. Let us assume that kbd underscore data be the address label of an 8-bit register which holds the generated character. Also, let a signal indicating that a key has been pressed be provided by setting to 1 a flip-flop called it as a key in KIN. So if I setting that KIN to 1, which indicates that you are reading the data or from the keyboard, and whatever the data or the key you pressed on the keyboard, that data will be stored as a 8-bit form in the KBD data, and the status will be stored in kbd underscore status. So the processor can read the status flag KIN to determine whether a character code has been placed in kbd data. When the processor reads the status flag to determine its state, we say that the processor polls the IO device. So the display includes an 8-bit register display data used to receive characters from the processor. It also able to indicate that it is ready to receive the next character. So this can be done by using a status flag, call it as dout, which is one bit in a status register display status. So these are the interfaces that we have here: KBD data. Okay, so KBD status and KBD count. These are the keyboard interfaces which we can call it as. So K in is a bit flag bit, KIR is a interrupt request bit here, like that here, whether KIE is whether keyboard is enabled or not. So these are the three important uh, uh, registers which are associated with the keyboard. Similarly, for what we are calling it as the display interfaces, here display data, display status, and display CONT, display CONT will be there. So this is what we are calling it as a 8-bit registers which we have here basically. So display interrupt request and display D out. This is another bit which we are setting about that display device status. So this is the reflection point where you are able to answer this question. So list the registers which are used for keyboard and display interfaces. Fine. So this is what as a sample program here. So which is a read wait and write wait. So read the Kane flag. Based on that Kane flag, branch to read wait if Kane is equal to 0. Otherwise, transfer data from KBD data to R5 register. This is what we are calling it as a read wait. Then write wait is nothing but read the dout flag, branch to write wait if dout is 0. Otherwise, transfer data from R5 to display data. This is what it happens here. Load byte R5 comma KBD data, store byte R5 comma display data. So these are the load and store byte instructions which are used for read wait and write wait program. So the outcome of this today's discussion topic is that, so after completion of this session you will be able to understand the process of how IO operation will be done and how IO devices are connected to the processor. Okay, so thank you.